Imagine waking up tomorrow and realizing that you're not the only you. Somewhere, in another dimension, another you woke up 5 minutes earlier. Another you never met your best friend. And another you never even existed. This isn't fantasy. This is the strange and mind-bending world of the multiverse theory, the idea that our universe might just be one bubble in an infinite cosmic ocean of universes. But how did this idea even begin? Let's travel back to the moment our universe was born. Nearly 13.8 billion years ago, the universe exploded into existence in a violent event we call the Big Bang. From a single point of infinite density, time, space, and matter burst outward. But what if the Big Bang wasn't a one-time event? What if it was just one of countless Big Bangs, each creating its own universe with its own laws of physics? That's the foundation of the multiverse theory. And to understand it, we need to look at cosmic inflation, the mysterious expansion that happened in the first fraction of a second after the Big Bang. According to physicist Alan Guth, during this inflation, tiny quantum fluctuations could have caused different regions of space to expand at different rates, each forming its own bubble universe. Our universe might be one of those bubbles, floating in an endless cosmic foam. Now here's where it gets crazy, each bubble could follow completely different physical laws. In one universe, gravity could be stronger. In another, time might flow backward. In one, stars might never form. In another, life could flourish in unimaginable forms. But among all these possibilities, could there be another Earth? Another planet, orbiting another sun, identical to ours? Mathematically, the answer could be yes, because if there are infinite universes, every possible configuration of matter must exist somewhere. Every decision, every outcome, every moment, all happening simultaneously across infinite realities. In one universe, you chose to stay home today. In another, you went out and changed your life. In another, you didn't make it this far. Welcome to the parallel universe hypothesis, the idea that infinite versions of reality exist side by side, like unseen layers of existence, separated by quantum walls we can't yet cross. But is there any real science behind it, or is this all just cosmic imagination? Let's dive into the physics. Quantum mechanics, the science of the very small, tells us that particles can exist in multiple states at once, a phenomenon called superposition. When we observe them, they seem to choose one state. But the many worlds interpretation, proposed by physicist Hugh Everett, says something while they don't choose, we just split. Every time a quantum event happens, the universe splits into multiple versions, each carrying out one of the possibilities. So every moment, new universes are being created, branching infinitely from every quantum event since the beginning of time. You might think, that sounds impossible. But quantum physics already proves that reality behaves in ways that defy logic. Particles pop in and out of existence. They can be in two places at once. They can be entangled, linked instantly across galaxies. So why not multiple realities? But hold on. If parallel universes exist, can we ever reach them? Some theories say yes, at least, indirectly. Physicists believe that if universes are close enough in the higher dimensions, they could occasionally collide or interact, creating ripples in cosmic background radiation, or strange gravitational anomalies we could someday detect. Some even believe that dark matter, the invisible substance that makes up 85% of the universe, might be a shadow effect from a neighboring universe pressing against ours. And that brings us to another theory, string theory. String theory suggests that everything, every atom, every force, every bit of matter and energy, is made of tiny vibrating strings of energy. These strings can vibrate in up to 11 dimensions. We can only perceive 3 of space and 1 of time, but the others could hold entire realities folded within them, invisible to our senses. Imagine pages in a book. Each page is a separate universe, flat, independent, unaware of the others. You live on one page, but all the pages together form the multiverse, stacked across higher dimensions. Now imagine if those pages, those universes, could occasionally brush against each other. Could that explain déjà vu? Could dreams, ghosts, or time slips be echoes from another version of reality bleeding through the dimensional wall? It sounds like science fiction. But the line between science and imagination is thinner than you think. Let's look at the cosmic microwave background, the oldest light in the universe. In 2015, astronomers noticed strange cold spots in this radiation, patterns that didn't fit normal physics. Some suggested they might be scars, evidence of another universe colliding with ours billions of years ago. If that's true, it means we're not just one universe. We're part of a multiversal city of cosmic giants, bumping shoulders in infinite space. And if there are infinite universes, then there must be infinite Earths. Somewhere dinosaurs never went extinct. Somewhere the Roman Empire never fell. Somewhere humanity never evolved. And yes, somewhere you live a completely different life, one decision, one heartbeat away. Now, let's push deeper. What about the mathematical universe hypothesis by physicist Max Tegmark? He says our reality itself is a mathematical structure, and every possible mathematical structure exists somewhere in the multiverse. That means universes where physics is different aren't just possible, they're inevitable. The laws of logic itself give birth to infinite forms of reality. Still, some scientists remain skeptical. They argue that the multiverse can't be tested, and science must be testable. But here's the paradox, maybe we're inside a reality that can't perceive beyond its own cosmic walls. Maybe proof is impossible. Because we're part of the simulation. That's right, the simulation hypothesis ties into the multiverse too. If advanced civilizations can simulate entire universes, and if such simulations are possible, there could be billions of them, each indistinguishable from the real one. And that would mean we might be living in one of the countless simulated layers of existence. So maybe the multiverse isn't just cosmic. Maybe it's digital. Every particle, every atom, every neuron in your brain might be part of an unfathomable computation happening beyond our reality, and each simulation could spawn new simulations, new universes, new versions of you. Infinity, within infinity. But let's pause. Because there's something deeply human about this idea. The multiverse isn't just science, it's a mirror of our choices, our possibilities, our hopes and regrets. It's the idea that somewhere, every dream you had came true. Every loss never happened. Every path was walked. It means that existence itself is not limited, it's eternal variation. Now, back to the biggest question, if other Earths exist, could we ever meet them? To do that, we'd have to travel through higher dimensions, beyond the 3D fabric of our universe. Some physicists call these brain worlds, giant, multidimensional membranes floating in a higher dimensional bulk. If two brains get close enough, portals could open, wormholes between universes. Some even theorize that the Big Bang itself might have been caused by two universes colliding, releasing unimaginable energy that birthed everything we know. So, maybe our universe was born from the death of another. And maybe, one day, ours will spark another, continuing the eternal chain of creation across the multiverse. It's an idea that changes everything, even our concept of death. If infinite realities exist, then in some of them, your consciousness continues, in others, it ends, and in others still, it never began. Some physicists even link this to quantum immortality, the notion that your awareness might never experience its own end, it just continues in a universe where you survive. Eternal existence, through infinite possibility. The more we study the multiverse, the more we realize, the universe isn't just vast. It's endless. And we may only be seeing one drop in an infinite cosmic sea. So what does that mean for us? It means that every choice, every thought, every heartbeat matters. Because it might not just define your life, it could define a new universe. Right now, as you listen, another version of you is making a slightly different choice. And somewhere, in another dimension, they're wondering the same thing you are. Are we alone, or are we infinite? The answer might already exist. Not out there, but within the very equations of reality. The multiverse isn't just a theory. It's the ultimate story of existence itself, one where every version of you, every version of Earth, and every version of time lives on, forever. Because in the multiverse, nothing is truly lost. It just exists, somewhere else. And now, as we reach the edge of what we know, and what we can only imagine, one question still echoes through the cosmos. If the multiverse truly exists, then what does it mean to be alive in just one of its infinite versions? Maybe our universe isn't the center of existence at all, just a single note in an eternal symphony of realities. Maybe every dream you've had, every fear you've faced, every version of you that could have been, is still out there, somewhere, living that life. Human desire to look up, to question, to wonder. It's the spark that pushes us beyond stars, beyond dimensions, beyond the limits of what's known. Because maybe that's the real purpose of the multiverse, to remind us that reality isn't fixed. It's infinite. And as long as we can imagine new worlds, we keep creating them. So tonight, when you look at the sky, remember, those stars might just be reflections from other worlds, other lives, other yous. And in that endless cosmic ocean, one truth will always remain. The universe you see is not all that exists. It's only the one you're in, for now. Because somewhere out there, in another universe, the story continues.